Welcome to this explainer. Today, we are going to engineer the perfect DNA of an exam answer. I like to call this the geneticist approach to the Cambridge computer science exams because if you want an A-star, it all comes down to a very specific formula. Evidence plus analysis equals success. We're diving deep into why Cambridge principal examiners consistently report that processing arrayed data, specifically the bubble sort algorithm in the 9618 syllabus, is one of the most brutally misunderstood areas in the entire subject. To show you exactly what the grading room is looking for, I want you to imagine two students tackling a real, high-stakes Cambridge computer science past paper question. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads every single answer with raw computer science facts, writing huge paragraphs, but entirely misses the actual analysis. Then you have Sam. Sam rushes the paper, completely misses the command word requirements, and drops massive points on technicalities. Throughout this explainer, we are going to look at their flawed answers, see the red pen marks they get from examiners, and completely transform their approach.
Look at the core disconnect we have right here. Why do students, just like Alex and Sam, find interpreting complex binary representations or visualizing array shifts so incredibly difficult when the exam clock is ticking? It usually comes down to memorizing textbook definitions without actually understanding the mechanics underneath. Alex will sit there and just data dump everything they know about arrays, while Sam will ignore the specific scenario entirely. It's like having all the parts of a car engine scattered on a garage floor, but having absolutely no idea how to put them together so the car actually runs. But we are going to fix that right now. We're taking an exclusive under-the-hood look at the examiner's grading criteria. We are going to turn those raw, disjointed facts into high-scoring, tightly structured analysis that examiners literally cannot ignore.
Here is our roadmap to completely mastering array data. We'll start with core principles, move into algorithmic methodology, reveal the all-important method mark strategy, highlight the top examiner warnings, and cap it off with critical analysis and evaluation. Let's jump in.
Starting with Section 1, Core Principles and Building the Theoretical Architecture. We absolutely must start with the theoretical foundation. The assessment objectives for computer science target three distinct cognitive domains: knowledge, application, and analysis. Notice the massive gap between passing and excelling here. On the left, you've got our average student. This is Alex. Alex has a superficial breadth of knowledge, just regurgitating raw facts about loops and arrays without answering the actual prompt. But look at the right side. The top-performing candidate shows a connected, conceptual understanding that transfers seamlessly to entirely unfamiliar contexts. This is where we introduce the Peel framework: point, evidence, explanation, and link. Top students structure every single one of their computer science answers using Peel to ensure they hit the command words perfectly. Examiners don't want a brain dump. They want logical, structured reasoning. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
The crucial point here is that your knowledge of causal relationships has to integrate with other areas of the Cambridge syllabus. This applies whether you're studying 0417, 0478, 0983, 0984, 2210, or 9618. When you explain how a bubble sort swaps adjacent elements, you can't just state the basic mechanics and stop there. That's what Sam does, and Sam loses points. Principal examiner reports explicitly highlight that candidates who reference cross-topic connections, like how the sorting process directly impacts memory management or program efficiency, achieve significantly higher marks. This is the link part of the Peel framework. You make your point, you provide the evidence from the algorithm, you explain the mechanics, and then you link it to the broader system impact. It's all about showing the examiner that you understand the bigger picture.
Let's move into Section 2, Algorithmic Methodology and the Procedural Framework.
You simply cannot bypass algorithmic thinking. It is the absolute engine driving your success when processing array data. As defined here, algorithmic thinking requires step-by-step decomposition, selecting the appropriate data structures, ensuring efficient code implementation, and applying rigorous testing. But before you can do any of that, you have to decode the command words in the question. Are they asking you to describe, explain, or evaluate? If the command word is evaluate and you just describe the bubble sort, your grade is tanking. This is exactly where Sam rushes and misses the entire point of the question. You need to be able to seamlessly transition from decoding the command word to designing the algorithm to implementing and testing the solution.
This right here is what we call the computer science success blueprint. Whenever you tackle past paper questions, I want you to follow this exact standardized sequence. Step 1, deconstruct the question and extract the relevant data. This is your command word decoding. Step 2, select your analytical framework, meaning get your Peel structure ready. Step 3, execute your logic with clear, precise notation. And Step 4, present your final answer using the correct terminology. Let's do a live transformation. Imagine Alex wrote a messy, unstructured paragraph about array sorting. If we take our red pen, cross out the fluff, and force Alex to use these 4 steps, we instantly see red marks turn into green check marks. We strip away the unnecessary facts and replace them with targeted step-by-step logic. If you follow this procedural framework every single time, you are practically handing the examiner exactly what they want to see on a silver platter.
Let's dive into Section 3, the Method Mark Strategy. This is your ultimate safety net in the exam.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGC and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, look closely at this examiner alert. It is massive. Students consistently lose marks by not showing their working. When you are tracing a complex bubble sort, it is so incredibly easy to make one tiny indexing error and misplace a value in your final sorted array. But here is the secret. Even if your final answer at the very bottom of the page is completely wrong, method marks can absolutely save your grade. Never, ever leave your process blank. To practice this, let's do a quick interactive workshop. Challenge number 1, data scan. I'm going to put a complex 60-second timer on the clock in your mind right now. Imagine a massive, complex data array on the screen in front of you. Your job is to extract the core trend before the clock runs out. Do you see how the larger numbers are bubbling to the top? If you only write down the final sorted array and mess up one number, you get 0. But if you document each swap, pass by pass, executing your analysis with clear systematic working, that is exactly what captures those critical method marks step by step.
Moving on to Section 4, the top 3 examiner warnings. These are the critical mistakes you have to avoid.
You need to memorize these 3 specific mistakes straight from the principal examiner reports so you do not repeat them. First, students confuse cause and effect in the algorithm. They completely fail to explain why a specific pass triggers a specific array state. Second, they forget to check boundary conditions and edge cases. Ask yourself, what happens if the array is already sorted? What if it's completely reversed? And third, providing generic textbook answers that are not specific to the context given in the question. This brings us to challenge number 2 of our workshop, find the flaw. If I show you a sample paragraph that says,